So guys, I can see there's some seating up front. Ah, there you go. Ah, there we go. That's good to see you. Good to see there's a good crowd there. Thank you. So Richard, are you ready?
Yeah, sure.
Ready to go? Okay. So apologies for not being with you today. I'd love to be there today, but I'm unfortunately in Jakarta on business. But you know, the way the world is these days, we can join from anywhere. So tonight, we've got great pleasure in having Richard Schulkins, Regional Manager for Underground Technology from MAPEI, who's going to sort of talk to us about some ground conditioning and tunneling. So as an introduction to Richard, he's from Carbon School of Mines in the UK. He was educated there. He's got over 30 years of experience in civil engineering and as a tunneling engineer and manager, and he worked on the Channel Tunnel. I think everybody's worked on the Channel Tunnel in the past, but he's also been in Singapore and Asia for many years. So he's got a wealth of experience in underground solutions. And he's been based in Singapore for 24 years, joined MAPEI in 2005 as technical support for numerous tunneling projects. And as I say, he specializes in making TBMs go faster, which is something that we all want to see. And slurry, shaft sinking, ground freezing, etc. So some of those sort of technologies we need to get us moving more quickly in tunneling and underground. So tonight he's going to talk about the thought processes about how we go about do ground conditioning. And then this is really for EPB type machines. And he's going to discuss how we do the additives in terms of foams, polymers, etc. And give us some examples, I hope, of how that's going to, how we can make the tunneling easier and more productive. So without any more ado, I'd like to hand over to Richard to run through the presentation. Is that okay? You guys take over.
Yeah, thanks for the introduction. Yeah, I was a little hesitant about the Campbell School of Mines because the thing about the Campbell School of Mines is everybody says anyone who went to the Campbell School of Mines, the first thing they say is they went there. We better now?
Yeah, we can hear you.
Anyway, I was just denigrating Campbell School of Mines. No problem. Anyone who knows about the Campbell School of Mines knows that we're a little bit of a strange bunch. Anyway, thanks for the introduction, and yeah, here we go. Thank you. Okay. The first thing I'd like to point out is that tunneling is spelled incorrectly. It has two L's. Yeah, I just like that point. Yeah.
Richard, we know that, but we're using the American version, so yes, I agree. Anyway, sorry.
Sorry, it's not important. So there's a lot of myths surrounding ground conditioning. A lot of people find it very complicated, and they think that it's some kind of weird thing, but it's not. And we've found calculations on the internet, such as the one that we see here, that's totally nonsense. No, it's not. At the end of the day, soil conditioning is about adding enough conditioning to soil to put it in your hand and squeeze it so it can squeeze through your fingers. That's better than 99.9% of lab tests that you'll ever do. And this is the first thing I'd like to say. It's a little bit controversial because a lot of people have written PhDs and all sorts of things on it. But at the end of the day, If you can squeeze it in your hand, it's going to work. So this is what we're looking for. We're looking for taking a dry soil, turning it from a dry soil into a good plastic, deformable consistency. Low in friction because you want it to move within the chamber, you want it to come out the screw conveyor, you want it to go onto the belt, blah, blah, blah. And the other thing that's important is that when you add ground conditioning, you want the soil to be less permeable. When you're in especially saturated ground conditions, you want the soil to be impermeable so that you can travel through the soil and not bring additional groundwater in that you need to handle. I am going to rattle through this because I've got half an hour. Apologies. I think this is the sort of like the given rule for suitable for EPB when you have your granulometric curve. You want your soil to be somewhere in the middle of these bands. And the analogy I give is something that I think most people can relate to is concrete technology, where if you have cement, fine sand, coarse sand, small aggregate, coarse aggregate, then you're able to have a flowable soil. Sorry, I'm not very good at holding the microphone to my face. But yeah, so if you're missing any of these size fractions, then you need help. If you have all of the size fractions, you probably don't need ground conditioning at all, other than to avoid friction or maybe some sort of like strange situations. But if you have missing size fractions, you need ground conditioning to take up the part that's missing. Yeah. Sorry, I slipped into Singlish. So everything in the Philippines so far seems to be EPB. Slurry machines are only applicable where you have very coarse aggregates or you have coarse soils and this and that. But nowadays, I think with our technology, I think we would never say get away from slurry machines, and I'm sure Heron Connect would kill me for saying that. But we can get through most ground conditions without the need of a slurry machine, which is okay. Sorry, sir. Carry on. Why do you need ground conditioning? You need face stability. The first thing you need to have kind of a homogeneous plastic paste that you're pushing against the face with. When you're pushing against the face with a liquid, you've got a uniform pressure on the face. You're not point loading, so you're avoiding soil from dropping in from above, below, from the face. You've just got this plastic mass pushing against the face that avoids. Yes, sorry, I was trying to make the video work. If anyone doesn't know what ground conditioning is at all, then it's foam blasted from the face of a tunnel boring machine. The second thing ground conditioning helps with a lot is wear. The last thing you want is for your tunnel boring machine cutter teeth to wear away because they're very expensive and very difficult to. My voice has completely changed. Yeah. Yeah, so you don't want your screw conveyor to wear out, you don't want your tools to wear out, be it rippers or scrapers or roller cutters. You improve the flow. The whole thing about tunnel boring machines is when you work on EPBs especially, you begin to understand it's a factory production cycle. And you want, from the beginning, you want to get the cycle correct. So you want to excavate as quickly as possible, you want to build your rings as quickly as possible, but part of that is getting the soil away from the face, into the chamber, into the screw conveyor, onto the belt conveyor, out into the skip, and you need to be able to tip from the skip into the muck pit and also the muck away. And there are a lot of different restrictions in different countries where ground conditioning can help a lot with these kind of situations. This is a good example. It's a great example because it was my tunnel boring machine of exactly how you'd like the soil to come out like toothpaste. Same job. This was working for Nishimatsu, where we decided we didn't want to use ground conditioning for economic reasons. And we found out that after 100 meters, we'd wear the rippers out to nothing. And these things weigh 25, 35 kilograms. And when you're trying to change them in the front of a tunnel boring machine under compressed air, it's a particularly shitty job, to put it nicely. And that was back in the day. I could even get through the hole into the front of a TBM. Foam, lots of different types of foam. Sorry for the MAPEI plug, but you get pure foam, you get foam that's anti-abrasion, you get foam that's got polymer added into it to add to the stability of the bubble and make them last much longer. You get foam that's got dispersant added into it already, which in theory helps disperse clay better. And you get nowadays the big push, especially in Europe and Australia, is the environmentally friendly foam. So I suppose the first question is, what is foam? Foam is a product you buy from MAPEI or all the other cowboys. But normally you can go from sort of 1 to 3%. And the concentration of the foam is analogous to, as I said to you before, if you think back to the concrete analogy where you've got size fractions missing, you need to add more foam where you have lacking fines or sands or silts. But at the end of the day, you need 30% fines. But you still need higher foam concentration when you have various size fractions missing. So then you come to the next choice you have to make is what should be the expansion of the foam. And this is, in my opinion, of working on probably a couple of hundred tunnel boring machines now, is the foam expansion ratio is a little bit irrelevant, and is also the most dangerous one to manipulate. So normally I'll go onto a tunnel boring machine and I'll set the foam expansion ratio to 10%. Sorry, times 10. So when you've got times 10, it's perfectly okay for 99.9% of tunnels. But the reason I say this is if you adjust on the tunnel boring machine, the foam expansion ratio, you change it from times 9 to times 8, or you times it to times 16, then the change you're making is tens of percent. And quite often you leave your tunnel boring machine running dry or super saturated wet because it's a huge step in the liquid that you're injecting into the front of the tunnel boring machine. Whereas changing the concentration or the foam injection ratio, which comes next, is not such a big step. So my recommendation, don't ever change the foam expansion ratio. The foam injection ratio is if you have 1 meter cubed of soil, how many liters of foam do you add per meter cubed of in situ soil? It varies from ground to ground, also varies if the ground is dry or wet. But in general, the foam injection ratio is set on the TBM between 30 and 60%, or 300 or 600 liters per meter cubed of soil. You can play around with that, and we do. Because typically, a lot of soil is a long way below the plastic limit. So you need to add a lot of water before you add the foam. Something analogous to when you wash your hair. You wet your hair before you put shampoo on. If you don't wet your hair before you put shampoo on, you don't make foam. It's the same on a tunnel boring machine. It's ridiculous to add foam to build up the water content. You're just wasting money. Typical values. What our way? Who said the video was going to work? An example of not adding enough fluid. Because a lot of ground conditioning is all about adding enough fluid. People think it's all about the chemical. It's not always about the chemical. It's about just having enough moisture to actually make things happen. Next video, sir. So you can add a bit more fluid and you can get perfect ground conditioning, and it might not actually have much to do with the chemical at all itself. It's just basic rule of you need to add enough chemical to get the soil beyond its plastic limit, between its plastic limit and liquid limit, and so it can have this flowable mass. So that's foam very briefly, because I do only have a very brief amount of time to talk about it. But polymers, I try and encapsulate, oh, quite an appropriate word, in a few words. Short chain polymers are good for lubrication, and they help a lot with moving soil around. Long chain polymers are good for absorbing water. When I say absorbing water, again, I give a ridiculous example. It's the same kind of polymer that you put in children's nappies, or since we're in the Philippines, diapers. And it's the same chemical, you just add in there. The more you add, the more they absorb water. And they can absorb up to 300 times the water. And that's it in a nutshell. However, there are lots of different types of polymers. There are man-made polymers like polyacrylamides, blah, blah, blah. But there are lots of natural polymers, but natural polymers aren't as effective as the man-made ones. The man-made ones are much better. They're not toxic. They don't bioaccumulate, but because they don't biodegrade, a lot of countries get a little bit nervous about them. But like I say, if you put them in children's nappies, they really can't be that bad. MAPEI polymers, we have a lot more. Another thing to say about polymers is that, especially polyacrylamides, when you add polyacrylamides to clay, they render clay non-sticky. So they change the ionicity of the surface of the clay particles and stop them from absorbing water. It's just a good example. The one on the right is where you mix clay with water, and the one on the left is where you mix clay with a 0.02% of polymer. I think in French that's called fuck all. This is the complicated version of what makes soil sticky on a tunnel boring machine. It's by a guy from Bochum University, Heron Connect's greatest friends. Yeah, sorry, I'll leave that there. But yeah, it's quite interesting. If you've got soil, you can plot your parameters on here and you can see whether you're going to get any potential sticky problems or not. However, when all said and done with ground conditioning, this graph goes out the window. This is a project we did a couple of years ago in Bangkok. When you open the guillotine gate, the whole world rushes through. Anyone who's worked on an EPB machine before, you know you can open the guillotine gate 20 millimeters, 21 millimeters, 22 millimeters, and then the next thing you know, the world rushes through. However, if you add a suitable polymer, that was an aquifer as well, by the way, in Bangkok. This is 30 minutes later. you can control the ground conditions perfectly by just adding polymer. So it's not something to be scared about when you have too much water, unless it's ludicrous, in which case then we're looking at slurry machines. Same deal. No, the video didn't work. Sorry. I'm not doing that. Okay, no problem. Anyway, like I said, polymer basically turns slush into something that you can manipulate with an EPB machine. A few jobs that we've done around the world. It makes a huge difference using polymer when you have a lot too much water. Again, we have an affiliation with the Polytechnic in Turin, and we do all sorts of testing here, but it's just a few random examples of what we can do. There's one last kind of ground conditioning that people get excited about is clay dispersant, and I'm a little bit iffy on this one because if you put a lump of clay into a clay dispersant, by the nature of clay is impermeable, so it doesn't actually disperse it. When you've got silty, sandy clay, yes, it works very well. But if it's in pure clay, you need to think more back to a polymer. This is the theoretical picture where if you want to do a cut-ahead intervention, you can put clay dispersant into the face and everything will slump away and everything will be mightily clean, but it is not actually the practice. We can say it is, depends who we're talking to. Another version of the high clay thing, but the other things that we can do that a lot of people aren't aware about on earth pressure balance machines is a lot of times you don't have enough fine materials, but there are situations where you have a, say a 3-kilometer tunnel and you have a 30-meter section where you have no fine material at all. It's perfectly okay to inject fine material into the face and utilize that fine material to manipulate the paste within the chamber. And we have various ways that we can do that. We have done it on many jobs where slurry machines, everyone thought, or EPB machines, they thought, oh no, it's lost, we're screwed, we should have had a slurry machine. But a little bit of knowledge, you can get through all of these situations. When there's way too much water, you can add the super absorbents, the MAPEI kind of stuff. And we have also a range of high anti-abrasive foams as well. The jury's out. I always like to be very honest about my presentations. We can show there is a reduction in abrasion, but it's not as significant as we would like. Otherwise, we'll be using ground conditioning on all rock TBMs as well. Practicalities, quick as I can. When you have the concentration of the foam expansion ratio, the foam injection ratio, in theory, that's all you need to know to set all the parameters on your tunnel boring machine. And that's a good starting point. And we can do a lot of laboratory trials to reconfirm what we've done in the laboratory. However, it's still not as comprehensive as the first 20 meters of tunneling. You still need to be on the TBM and you still need to be making these changes on the TBM as it starts. Everything's great in theory, but the practicality, you never really know what the moisture content of the soil is in situ. You never really know what the fine contents are, because when you do a force hole analyses, then a lot of fine material disappears. So there's a whole world of things that are missing in the real world that you can only find out when you're actually on the tunnel boring machine and actually tunneling. I shouldn't say it's black art, but there's a lot of things that we do are counterintuitive. A lot of when things are going horribly wrong with ground conditioning, quite often the best thing you can do is do exactly the opposite of what you think, and you might find it helps. Every tunnel boring machine clogs up at the beginning. Normally that's because they're cutting through cement diaphragm walls, and nobody takes account of this fact. They don't put in any kind of cement retarders, and typically when a tunnel boring machine starts in the first 10 meters, it's going to choke up because nobody considers what they need to do to stop it choking up going through cementitious material. Common sense. The other thing is that one of the things that I find remarkably annoying on tunnel boring machines is when TBM drivers make adjustments every 5 minutes or 5 seconds because they think that's going to make a change. But typically it's going to take at least half an excavation cycle before you see any meaningful change. For that reason, you need to have one person in charge of ground conditioning. You can't have lots of people coming down and making various changes because it's going to make a world of problems for you. Somebody needs to have it in their head exactly what's going on. Rule of thumb, if you're buying ground conditioning, you need 1 litre per meter cubed of excavated soil. So anybody who's looking to tender a project, that's kind of an interesting number. No projects are the same. You've got 2 tunnels side by side. 2 tunnels side by side. You might find one tunnel's going fantastically well with one system, but the tunnel next door is going fantastically well with a completely different system. It's a little bit of a enigma. I don't know how to explain that, but it's quite common. Always have a backup plan. So if you think you might hit water, always make sure you've got a lot of polymer, or not a lot of polymer, enough to get you out of the ship. 2 or 3 cubic meters of polymer, just to make sure that you're not going to hit a world of pain. Obvious things like interfaces between ground conditions. So if you're going from clay into rock or clay into alluvium, these interfaces are normally fault zones associated with high water and high risk. So always make sure that everybody on your TBM is aware of hitting these interfaces or where they think these interfaces might happen. Okay, sorry, Paul, but never believe. I'm not pinpointing Heron Connect. I'm not at all. But sometimes on tunnel boring machines, you'll say that your foam lines are connected to 1, 2, 3, 4, 5, 6. But quite often you'll find that it's not what they say on the log, and what comes out of the foam generators and what comes out of the end of the foam generators is quite often quite radically different from what the computer says. So be wary of believing exactly what the computer says. We love Heron Connect, just not their affiliation with Condat. Everything else is great. TBMs come with 3 settings. Manual, where you can take each manual line and inject manually whatever you want. Foam injection ratio, foam expansion ratio, blah, blah, blah. Flow rate is specifically. But, and semi-automatic is a little bit different, where you turn on the machine and they'll inject a set flow rate. But we find this, if we can, and this is where Heron can come into their own, and they're very good at it. They have the fully automatic system, and you set your concentration, your foam expansion ratio, your foam injection ratio, and no matter how fast or slow the machine goes, the ground conditioning system will inject enough to compensate for that. Example, if you go from 30 millimeters to 60 millimeters a minute, you don't get this kangaroo effect or bouncing effect where you have too much ground conditioning, not enough ground conditioning, too much ground conditioning. When you get the fully automatic system set up properly, the TBMs can fly. I'm just making my point again. Yeah, keep it simple. Don't try and use too many different types of ground conditioning. It's don't get too theoretical about the bubble size. Lots have been PhDs written on the size of bubble size, on the effect of speed and the pressures, blah blah blah. But practically on the TBM, it's not important. I'm not going to be popular for saying that. It's just my opinion. Obvious things: if the ground's dry, wet it. Start using ground conditioning to wet the soil. Like I said, you need to wet your hair before you put shampoo on. Same. Reiterating, if you can squeeze it in your hand, it's perfect. You can use Abrams cones, you can use slump cones, you can use all sorts of laboratory tests, but at the end of the day, that's the one that matters. How many people have worked on an EPB? I know a lot of people have worked on EPBs and they open the guillotine gate a little bit and air's going through there. And if it's not air, you've got a lot of water or stuff or this. There are very simple ways of getting around that kind of problem. And as I said before, again, only one person should be allowed to change it. The most important thing about ground conditioning, if you don't do it, you're never gonna know. You can sit in an office, you can say, oh, I need lab reports, I need this, I need that, but it's yeah, you're just not going to have a clue unless you actually try and do it yourself. It's really important that you do it yourself and understand what it is you're trying to do and what you're trying to achieve, because there are too many office warriors and arse polishers that think they have all the answers for ground conditioning and tunnel boring machines, but unless you do it, you can't possibly know how to do it properly. Not sure why I put that in. That was my TBM. We didn't use ground conditioning. It came out the end and there was nothing left. I was thinner one day. The only other thing that you need to adjust on the tunnel boring machine is that you have maybe 5, 6 injection points on the face of the tunnel boring machine. The most important places to inject ground conditioning are on the nose of the machine, on the gauge or the outside. And it's just a stupid graph to explain that the cutters on the outside of the TBM are doing significantly more work than the cutters that are in the center. The reason you need to inject more in the center is you need to, this is always a weak point on a tunnel boring machine where you get chokages because the soil's not able to get away from the center. So the more you can blow into the middle, or the more you can blow into the gauge, the outside, the better. This is just a distribution thing. Like I said, you can set the distribution on your tunnel boring machines, so that would be 32% in the center. Number 6 will be the screw conveyor. I think that's a screw conveyor as well, and that's the gauge. It's not a really good example of what I've just explained. Yeah, just to finish up, the whole world's going green now. MAPEI with it. We have everything that we can possibly do to reduce the environmental footprint of everything we put on a tunnel boring machine. We strive our best to do. This is a project in Santa Lucia, which is near to Mugello, if anyone's a fan of MotoGP. But they built all of these muck pits to put the soil, 4 weeks of soil they wanted to put into these muck pits, 4 or 5 weeks of soil to make sure that all the soil had fully biodegraded before they put it back into the ground. So they had to store it in this situation, and fortunately, with the advent of all of our environmentally green polymers, I don't think they actually foams. They don't think they filled any more than 2 of those bays because it was fully 89% biodegraded within 2 days. And we do a world of tests to prove how environmentally green it is. It's made from the tears of angels. You can squirt it into babies' eyes and all sorts of stuff. A random example. We do a lot of tests in universities here, there, and everywhere. This is just using MAPEI foams against other people's foams. It does make a difference. It's worth considering because we're not necessarily more expensive, but at least we try and make the effort. Same, different package. And this is just to show that I take my job home. This is some empirical testing that I did at home. And that's all I have to say, but I'm really going to do a very, very quick, for people who don't know what foam is, I'm just going to do a quick little.
Do you mix or I mix?
I'll leave the microphone here. Now. Sorry.
You want to put it on or I put it on? Need assistance?
We picked up some soil from outside. It was in a plant pot, and apparently Bob's in a lot of trouble for taking the soil out of the plant pot. It's got a few leaves in it, but we're just trying to make a point. So, 1% of foam. I've already measured 100 milliliters of water. Ad hoc foam generator. What's the plan? No. Ad hoc foam generator generates it's a 1% concentration, generates a 7 times foam expansion ratio. Obviously, the foam isn't as good as if you use on a proper TBM where it's a completely better. The leaves are in there to give the environmentally green effect. It's also a very good way of checking whether competitors' foams are shit or not. If you can do it with 1%, you can find a big difference between different people's foams. Random manila soil from a painter outside. Should be like shaving foam. Breathe down. Okay, we've generated perfect soil for EPB in no time at all. Well, admittedly, it's very easy soil to condition. But then the question is, what happens if your soil is too wet? So exactly what I'm saying. You squeeze it through your fingers, perfect. Good to go. But then you're going to hit aquifers, you're going to hit fault zones, you're going to hit all sorts of nonsense. Hold it up. Hold it up. So. And we'll screw it up a little bit more. And, so now if you open the guillotine gate with that, it's going to go, and you're going to be flooded. The whole world's going to go to shit. It looks like shit. So, 1% of polymer. Particularly unpleasant stuff. You don't want it on your clothes when you go home. Your wife's going to be very unhappy. Lipstick. It's worse than lipstick. It takes you a good couple of hours to wash this stuff off. But this is 1% product. Before and after. Okay. Yeah, I need to put more. Not ideal, I can tell you. It's not the best example I've ever shown in my life. Maybe manila planter boxes aren't as full for polymer as I was hoping. It's certainly better, but it's not as good as we want. Yeah, it's not as wet as we want. Okay. We've got a solid, solid. I say we've got manageable soil. So, yeah, that's it. Please get pissed.
So before we go on, Richard, Bob, it's great. Bob, it's great to see you getting dirty, getting your hands dirty. And Richard, thanks for giving us another way to have a soapy. So it was good to see the other use of the foam. So can I just ask whether there's any questions from the audience, either in Elks Club or online? I think there's I don't see any questions online yet, but please put your questions on there if you want to have Richard answer some of your burning questions that you have for for the presentation. Where are we? Let's do this.
What's the something?
What's a soapy?
It's a bath, I think.
It's a bath, yes, of course. So, Richard, can I ask a question? So can you, at the beginning of the presentation, you talked about improving performance, right? So you talked about improving performance of the TBM, and I understand it's about making it consistent. So, in those situations where they either have the soils too loose or too runny, what is your typical sort of improvement that you can get in these situations? And maybe it's about uniformity of the soil, it's about consistency of the soil, but how do you measure the improvements that you get in performance of the TBM in terms of progress? Well, can you use the yeah, that's it, perfect.
There's a raft of things that you can look at on the tunnel boring machine. Obviously, the first one is still what comes out of the guillotine gate, whether it's manipulable or not. But you're also looking at the torque on the cutter head. You're looking at the thrust force, and you're trying to balance these things. The one thing that I never really stressed in the presentation is that always this needs to be injected to the face. A lot of people think that polymers and the like, well, not foams, but polymers, they need to be put into the chamber. But everything's all about getting the torque reduced on the cutter face. And that's the goal that we're always trying to get as many things through as possible. And one of the things that I should have said as well is that certainly if you've got an anticipation of any kind of wet conditions, you need to have the polymer system built into the TBM. Yeah. Before it arrives, because 90% of tunnel boring machines don't have that, and it's always a retrofit that takes a lot of time and cost.
Yeah. So how quickly can you mobilize if there is an issue with a TBM, in terms of getting the product and getting that sort of solution implemented?
Well, me, myself, I.
No, I mean, getting that. Okay, so there's a retrofit needed to the TBM, right? And there's no anticipation of needing the additives, right? So how long does it take if you don't know that there's a problem versus what you do know there's a problem and then applying that those additives?
If you've got a tank on the tunnel boring machine where you can pre-mix the polymer, then that's okay. You can do it fairly quickly. But if you've got no provision to mix it on the tunnel boring machine, then you need to buy a dosing unit, an inline dosing unit, which you can typically buy from a French company called Dosatron. And you should be up and away within a week, but normally a week's a long time in tunneling, and you should normally have the product on site as well, because if you don't have the product on site in the Philippines, then you're going to have to import it. Well, from our perspective, from either Australia or Singapore.
Right. Okay. So there's a question come online. Does MAPEI also carry flocculants for sludge dewatering? So you have that as well in your arsenal of solutions.
Well, thank you for the totally unrelated question, but yes, we do have the full range of flocculants, coagulants, and dewatering solutions as well.
Yeah. Okay. Good. So any questions on the floor in the Elks Club? Anybody got any questions there?
You mentioned the consumption, how much you need to contribute to.
Yeah.
So you mentioned a consumption rate in terms of what we should be considering, which is about a certain volume per cubic meter of spoil. I just wanted to understand in terms of the storage capacity, how these things are stored, where, and then the logistics of how you get them to the TBM, just in terms of understanding that aspect. And then the other one is specifically in terms of importing and using in the Philippines? Are there any limitations in terms of restrictions, in terms of what can and can't be used, and time frames for procuring this type of material?
Time frames, there's no restrictions for the Philippines for sure. There's nothing that we sell underground that's going to alert anybody to any kind of environmental problems or any kind of, I don't say we're squeaky clean, but we're pretty good at it. But when it comes to storage on a job site, normally it's delivered in either bulk tankers or IBCs, and typically what you do on the tunnel boring machine is you'll take your IBC in on the train with the segments. You'll either pump it out or switch your IBCs over. Normally pumping it out because it's just easier to do that. But logistically, it's a breeze. Logistically, when you don't have a polymer system, is another issue.
Okay, thank you very much.
So there's another question online. So we'll take this one from Sorada. Why is it difficult to tunnel through sandy soils?
Sandy soil depends on your definition of sandy soil. Like I said before, you need 30% fines, and fine material is, I think it's classed as what you would consider in your mind as almost kind of fine silt. So you need a lot of silt material to operate an EPB effectively, and all the other size fractions as well. So we've come across a few projects where you have single size sand, and that's just a nightmare. And we have to do what I spoke about before, where you actually have to add fine materials into the chamber to make the paste in order to excavate the soil. But sand, single size sand is quite a rare phenomena on tunnel boring machines. We've come across it a few times in Singapore, but normally it's got at least a certain percentage of fines in it. And a certain percentage of fines means that normally a bit of foam and polymer, you're able to tunnel through it, no problem. But extreme conditions, yeah, you need to inject fine material into the chamber. Hope that answers that question.
Yeah, that sounds good, Richard. Another question online. Dennis is asking, he's had previous experience of struggling to develop the plug in the screw conveyor when he hit 50 litres per second groundwater ingress. And he's asking, can the polymers that you've got maybe handle that flow rate or that type of flow?
Yeah, and particularly because you've got to bear in mind as well that initially you need to add quite a lot of polymer. But once you've added, say you add 1-2 litres of polymer per meter cubed inside the chamber, then you're kind of turning the cut ahead and you're rendering the soil more impermeable. So once you've got the soil to a kind of impermeable mass within the chamber, then you need to add much less to the face to control it. So you kind of have to overdose it in the beginning, but after you've overdosed it, then you're able to maintain control of the water actually coming in from the crown sides or even the invert. You just need to start off with the overdose.
Would you have a mixture of polymer and foam for that type of condition or not?
Case by case. If it was purely a water scenario where you're trying to control water, no, we'd probably just go for polymer because you're trying to avoid adding additional water for no reason.
Right. Okay, good. Any other questions on the floor? No. Okay, well, I think we're almost done, Richard. I think it's a great presentation. Thanks for doing that. And I have to say that I have to thank Bob and Richard for sponsoring the bar in the Elks Club. I'm really sorry I'm not there to also have a beer with you, but thank you for sponsoring the open bar. So you guys hopefully enjoy that when you're there. And just want to thank Richard in the usual way, please, everybody, to thank him for the presentation today and for telling us how complicated it is in terms of ground conditioning for tunneling works. But obviously, you guys are the experts. So thank you very much for that, Richard. So I have a couple of announcements. So just to follow on from that. So remember, Noto-san he gave us a presentation on Davao bypass, and we're trying to organize a visit, maybe in early December or early January, depending on whether we can get approval from DPWH to go. So we may be getting a chance to have up to 20 people to go for that. So we'll send out a notice and confirm details of how that's going to happen. It will probably be an overnight stay, and then go to visit the site, go and see what's happening for the tunneling for the Davao City bypass. So watch that space. Hopefully that's coming soon. Also, just a reminder, the next sort of talk is on the 17th of November. Gan Cheng Chian from Becker Art will tell us about the design of fiber concrete according to the Singapore Code. So that'll be quite an interesting talk about how that will be applied and the code requirements that they have in Singapore and how that's being applied. That'll be a face-to-face and online. And again, will be sponsored by Beckett Art. Oh, sorry, McAferry will sponsor the open bar for that one. So that's something to look forward to. And then just another reminder for the AGM and Christmas dinner. So please, we sent out the society newsletter in September, and just a reminder that we've got a Christmas dinner party at Enderun College in Upper McKinley Road in BGC or near BGC. So please, think about coming. It's going to be a great evening. We're going to have a Christmas pub quiz, or with the best table prizes, etc. Please bring along your partners and spouses, and we, get your registration in early because we've got limited numbers. But please, send us an email, reserve your places now, and we look forward to seeing you then. So that's it. Thank you very much, everybody, for that. Again, thanks to Richard and the team and Bob for sponsoring the drinks. And I hope you guys have a good evening, and see you again in November. Thank you very much, guys. Good. Thank you.